If you're looking for a machine learning tutorial that uses gradient boosting and solves a classification problem, this tutorial is for you. We'll be going into what it takes to build a gradient boosted classifier and also focus on the parameters of this model. So we'll be making use of scikit-learn as part of the Python programming language. So let's get started. As always, at the start of every programming project, we'll have to import all the necessary libraries. And what we'll be using today is pandas, scikit-learn, and that will be the two packages that we'll work with and import all the necessary submodules from. So let's just go and execute that step and import all the necessary libraries. As you can see, it's been imported, and the next step is loading our dataset. So what we'll do is we'll actually use the wine dataset straight from scikit-learn and then convert it into a pandas data frame just so that we can work more easily with it. Once that is done, we can then view our data frame and we can see what it primarily consists of. This is a dataset listing a bunch of different wines, and then in our machine learning problem we'll have a target where it is basically the class of wine that we have to predict. So now that we know this information, we can then create two variables, one with all of the input features and one with the target. Once we've done that, we can then go and split these data frames into a testing set and a training set. So as you can see, we're splitting it randomly. Now, once we have that, we are ready to create our gradient boosting classifier. And as you can see, that is exactly what we are doing here. And as promised, we will be discussing these parameters that are available in this gradient boosting classifier class from scikit-learn. So the first one is the number of estimators, and in a gradient boosted classifier tree, that corresponds to the number of stages where each estimator essentially tries and improves the error of the previous classifier. Then the next one is the learning rate. So this is the value that gets multiplied by this attempted error correction at every single stage. Then we have our max depth, which essentially tells us how deep each tree can go to and when to stop splitting. Another variable that closely matches that is the minimum sample split, which means in our case, and with what it's been said here, the tree will not split any further if it only has 2 samples left in the leaf. And then also we have the minimum samples leaf, which is essentially pretty self-explanatory. Then we have the subsample parameter, which is the fraction of samples used for fitting the trees. And then we have our max features parameter as well. So at every single step, this is a number of features to consider when looking for the best split. And then lastly, here we just set the random state to 42. However, in practice, that should not be too much of a concern. So we can now run this cell to create this gradient boosting classifier. And once we've done this, we can go and make some predictions using this classifier and algorithm with all of the parameters that we've specified. So that's what I'll do here. And just to show you, I have trained this classifier now on the data, and I have also created a prediction, which we can easily see by running this cell. And now we can see that our model successfully creates all predicts values for each single row of X. And then the last step is obviously to evaluate the model and find the accuracy. So what we discussed in this video recording is an overview of some very important parameters for the gradient boosting classifier in scikit-learn. And depending on your specific problem and data set, you may need to fine-tune these parameters to achieve your desired results. And there are a bunch of techniques that you can use to accomplish this. And this tutorial was just to give you a basic feel of what is the important parameters to look at.